Hello everyone and welcome to day 19 of our low-level design journey. Today we are going to dive into two of the most powerful and widely used design patterns, the observer pattern and the strategy pattern. Understanding these patterns will not only help you design more flexible and maintainable systems, but also prepares you for real-world coding interviews and projects. So grab your notes and let's get started. Before we dive deep, let's take a moment to understand what we aim to achieve today. First, we will thoroughly understand how the observer pattern works, its components, and where it shines the most. Then we will explore the strategy pattern, how it helps us deal with changing behaviors dynamically. After that, we will apply these patterns through hands-on mini projects to ensure we can practically use them. By the end of today's session, we will not only know the theory but also have built working examples. Let's go. Let's begin with the observer pattern. The core idea behind this pattern is simple yet powerful. When one object's state changes, all its dependents should be automatically notified and updated. This establishes a one-to-many relationship between objects where the one is called a subject and the many are observers. This pattern is crucial in event-driven programming where different parts of a system must react to changes elsewhere without being tightly coupled together. Now let's break down the main components involved in the observer pattern. First, we have the subject. This object holds the state and maintains a list of observers. It provides methods to add, remove, and notify observers. Next, the observer, an interface or abstract class that defines the update method, which is called when the subject changes. Then comes the concrete subject, an actual implementation of the subject interface containing the real business logic and state. And finally, concrete observer. These are specific implementations of the observer that update themselves when notified. By separating these responsibilities, we achieve low coupling and high flexibility. You might be wondering, when should we actually use the observer pattern? The answer lies in any situation where multiple parts of a system need to stay synchronized with some central data. It's a perfect fit for event-driven architectures such as chat applications, where new messages trigger UI updates, or financial apps, where stock prices update across multiple dashboards. Other classic examples include notification systems, real-time gaming leaderboards, and weather monitoring applications. Whenever you have a change that should ripple across multiple dependent objects, Observer is the way to go. Here's a simplified UML diagram representing the observer pattern. As you can see, the subject maintains a list of observers, and when an event occurs, it notifies all of them, calling their update methods. This setup creates a clean, scalable architecture where subjects and observers can evolve independently, promoting a highly modular system design. Moving on to the strategy pattern, this pattern is all about behavior encapsulation. It allows a class behavior to be selected at runtime. Instead of using conditionals like huge if-else blocks to choose behaviors, we delegate the responsibility to different strategy classes. Each strategy encapsulates an algorithm, and the context class simply delegates the work without worrying about which specific strategy is being used. This separation of concerns makes the system more flexible and extensible and testable. Now let's understand the building blocks of the strategy pattern. First, the context class, which contains a reference to a strategy object and delegates it to perform a specific task. Then the strategy interface or abstract class. It defines a family of algorithms but lets the actual implementation vary independently. Finally, concrete strategies. These are specific implementations of different algorithms or behaviors. Using this approach, the context does not need to know the details of each behavior, promoting open-closed principal compliance, open for extension, closed for modification. When should we reach out for the strategy pattern? Think of situations where you have multiple algorithms or behaviors that you might need to switch between at runtime. Common examples include switching between different payment gateways, choosing between different file compression algorithms, or deciding among different sorting mechanisms. Rather than cluttering your context class with complicated if-else or switch statements, the strategy pattern allows you to clearly plug in new behaviors with minimal changes. Let's take a look at the strategy pattern UML. Notice how the context holds a reference to the strategy interface, not to a specific strategy implementation. This allows us to change the algorithm dynamically by simply setting a new strategy object without touching the core logic inside the context class. It's an elegant and scalable solution for behavioral flexibility. Time to put theory into practice. In the first mini project, you will create a weather station application using the observer pattern. The weather station will act as the subject and track temperature changes. The display units, our observers, will subscribe to the weather station and get automatically updated when the temperature changes. This exercise will give you a solid grasp of real-world event-driven programming. Next, using the strategy pattern, you will build a simple payment system. Here, the payment service will serve as a context, while payment strategy will define different payment algorithms. You will create concrete strategies for credit card, PayPal, and wallet payments. Depending on the user's choice, the system should switch between different payment methods seamlessly without any messy conditions. Before we wrap up the concepts, let's engage in a thoughtful discussion. First, consider how exactly does the observer pattern help us achieve loose coupling. Then think about strategy pattern versus if-else statements. What trade-offs do you see? Finally, can you think of scenarios where combining the observer and strategy patterns could lead to even better system designs? Reflect on this, they will sharpen your system design intuition for interviews and real-world work. As you conclude today's session, make sure you complete your deliverables. Submit your two mini projects, the weather station build using the observer pattern and the payment system build using the strategy pattern. Additionally, write a brief reflection summarizing your experiences, challenges faced, and lessons learned during the projects. This reflection will deepen your learning. Here are a few pro tips to help you master these patterns. First, leverage the observer pattern. Whenever you are designing scalable notification-based systems, it pays off massively as system grows. Second, use the strategy pattern whenever you see growing complexity in decision-making logic. It will keep your code clean and extensible. And most importantly, confidently talk about these patterns during interviews. If you can explain not just what they are, but when and why to use them, you will truly stand out as a design-focused engineer. Thank you for your attention.